Hey everyone, welcome to probability lesson number 7. So tonight we're going to look at experimental compound probability. Okay, we know what experimental probability is. Now the word compound. Compound just means two or more. Okay, so looking at compound events. Compound events are going to be an event that includes two or more simple events. Okay, and simple events could be rolling a die, spinning a spinner, it could be flipping a coin, anything with one outcome. That is a simple event. Now, if we put two or more together, there's going to be more outcomes, and that's what's called a compound event. Now, finding the probability of a compound event. If we look at this, right, our table, the outcomes, red, blue, or yellow. Okay, let's say that was spinning a spinner with those colors, right? There were three colors there, and then flipping a coin landing on heads or tails. Now, if we read this table, this number 6, that represents red with heads, right? So 6 times they got heads and red. 7 times it was heads with blue. 3 times it was heads with yellow. Tails with yellow happened 6 times. Tails with blue is that 3 right there. And then tails with red, that's going to be 5. Okay, so when we add this all together, right, the total number of trials, we have 6 plus 5, that's 11, plus 7, that's 18, plus 3, that's 21, plus 3 is going to be 24, plus 6 is going to be 30. So the total number of trials that they did was 30. Okay, so we know our denominator is going to be 30 because we're looking at compared to the total number of trials since it's experimental probability. If we look at the probability of heads and blue, okay, we go over to heads, go over to blue. Right where they meet, we have a 7. So the probability, experimental probability, of landing on heads and blue is 7 out of 30 because it happened 7 times out of the 30 trials. If we're looking for heads and yellow, here's heads, go over to yellow. It happened 3 out of 30 times. And 3 out of 30 simplifies to 1/10. So that's the probability there. Now we have tails with yellow. Okay, tails, go over to yellow. It happened 6 times out of the 30 trials. We could simplify this one as well. It becomes 1/5. Now we have tails with blue. Tails, go over to blue. 3 out of 30. Which, just like before, simplifies to 1/10. Okay, so those were the compound events we're looking at. Now, we're looking at the probability of blue. Okay, but it doesn't tell us if it's heads with blue or tails with blue. All we care about here is that it was blue. Now go over to blue. We have 7 and we have 3. Right, so 7 times it was heads with blue. 3 times it was tails with blue. So blue happened 10 times. So 10 times out of the 30 trials, which simplifies to 1/3. Okay, probability of heads. We need to add up all of the heads. Whether it was heads with red, heads with blue, heads with yellow, we don't care. It's just that it was heads. So we add 6 with 7 and 3, and we get 16. Out of 30, which we can simplify to 8/15. Okay, so it's not much different than our other experimental probability, but now we have two events going on. Okay, let's try another. So a jeweler sells both silver and gold necklaces in 3 different lengths. The table to the right shows the sales from last week. Use the table to find the experimental probability for each of the following. Okay, looking at the table, silver necklaces, gold necklaces, 12, 16, and 20. Okay, there's a total of 75 different outcomes here, or different trials. Now we're looking at the probability of a 12-inch gold necklace. Okay, here's 12 inches. Over to gold, it's going to be 22. So this becomes 22 out of the 75 total outcomes, or total trials. Now a 20-inch silver necklace. Here's 20-inch silver. There happens to be 5 out of 75. Okay, now 5 out of 75, we can simplify that. 5 goes into both. We get 1/15. The probability of a 16-inch necklace. Now here, they don't say 16-inch gold or silver, so we have to count all of the 16-inch necklaces, right? So we have 16 plus 8, which is going to give us 24. So 24 16-inch necklaces out of the 75 that they sold. Okay, next, 20-inch gold necklace. Okay, 20-inch gold. Here's 20-inch. Over to gold. 12 of them. So they sold 12 20-inch gold necklaces out of the 75. Okay, 12 over 75, we can simplify that. We can divide both by 3, and we're going to get 4/25. Okay, now the probability of just gold. So if we're looking at gold here, right, we don't care what length it was, we just care that it was gold. 22 plus 8, that's going to give us 30, plus 12 is going to give us 42. So there were 42 gold necklaces still out of the 75, which simplifies to 14/25. Okay, so this is experimental because we're not going on theory, we're going on what actually happened. Right? These are the necklaces that were sold. Before we were looking at the different outcomes that actually happened. So compound probability, there's 2 or more events. We can look at tables like this, and then we can figure out the probability. Always comparing how many times it happened to the total number of trials or total number of outcomes that happened. All right, I'll see you guys later.